Hello everyone. I welcome you all for discussion on another interesting project. This study focuses on biomachining of alloy steel with green manufacturing perspective. The term biomachining struck me during my tenure at NIT Jalandhar. In order to explore it further, I collaborated with my chemistry teacher, Professor Amanpreet Kaur Sodhi of GNDEC Ludhiana. Thus, I continued this work during my tenure at IIM Amritsar, with Tanveer as our M.Tech candidate. So, let's discuss it in detail through coming slides. In this era of globalization, manufacturing performance is important for economic growth of countries, wherein metal machining industry poses high consideration for sustainability issues. As we all know, metal machining is basically a process of removing materials using sharp cutting tools. However, in recent years, manufacturing technologies with environmental focus have started gaining significant attention. Despite high productivity, traditional machining processes pose various environmental concerns. They produce a large amount of wastes in the form of solid, liquid, and airborne particulates. Cutting fluids especially damage the environment and increase as much as 30% of manufacturing costs. Moreover, inhalation of metal dust cause health problems in workers. Additionally, heat-affected zones or mechanical deformation leads to significant increase in energy consumption. Thus, all the mentioned issues indicate the need to explore other sustainable machining techniques. Biomachining is a green manufacturing concept and utilizes microorganisms to remove material from surface of workpiece. Microorganisms either consume corrosion byproducts or produce corrosive species during their metabolisms, which depolarizes anodic or cathodic reactions. The process has gained significant importance over conventional machining methods, especially due to minimal energy consumption, and further eliminating the use of hazardous cutting fluids. Microbiologically influenced corrosion is commonly observed in various natural and industrial environments. The biomachining mechanism, in case of bacteria, follows redox reaction, where ferrous ions gets converted to ferric ions leading to metal removal from the surface. However, in case of fungus, acidolysis reaction takes place where sucrose is converted into citrus acid resulting into leaching of metal. The details of mechanism have been provided in this published paper for further reading. The current slide present details about published research papers within the domain of biomachining. As of now, microorganisms such as AcidothioBacillus ferruccidens and Aspergillus niger have been widely considered for the studies in comparison to other bacteria or fungus. However, different materials utilized for studying the influence of different bacteria or fungus have been copper, iron, nickel with little less focus on alloys and ceramics. Lastly, most commonly studied physiochemical indicators have been specific metal removal rate and surface roughness, with operating parameters being shaking rate, machining time, pH and ion concentration of solution. The graphs presented here highlight SMRR and surface quality trends from the published literature. From the first graph, it can be inferred that material removal rate is good at less pH being acidic in nature, and tends to decrease as pH becomes basic in nature. However, the second graph highlights better SMRR results for Aspergillus niger and AcidothioBacillus ferruccidens in comparison to other microorganisms. As far as surface finish is concerned, the smoothness is quite obvious based on before and after machining SEM images. Based on the initial literature survey, this study tends to explore the feasibility of biomachining on EN19 alloy steel due to its significant importance. Further, efforts have been made to evaluate the performance of AcidothioBacillus ferruccidens and Aspergillus niger in comparison mode. To begin with, only SMRR indicator has been considered in current context. The study has been conducted in 3 phases to achieve desired results. Firstly, culturing of bacteria and fungus has been done to be utilized for machining. However, we will be providing only brief details on the culturing process, as the entire process is available in paper for detailed reading. Secondly, the details on how the workpiece has been prepared for further processing has been given, along with SMRR calculation formula. Lastly, details on results with desired discussion has been provided based on trials conducted. Initially, a solution in plate media has been prepared containing 5 ml MTCC sample and 10 ml PDA solution. Then, another flask was prepared containing 250 ml of sterilized PDA solution. Finally, the solution in plate media was added to the flask having PDA solution. The flask was then sealed and kept in an incubator at 35 degrees Celsius for 7 days. After that, another culture flask was obtained having 10 ml of final solution for desired machining process, wherein similar amount could be taken for each experimental condition. Initially, the salts as mentioned in paper were added to a flask having distilled water, which was then autoclaved at 121 degrees Celsius for 30 minutes, in turn providing us with solution A. However, solution B consisted of 160 grams of ferrous sulfate, and 1000 milliliters of distilled water mixed thoroughly. Later, half part of solution A has been added to 1/4 part of solution B, along with 25 milliliters of bacteria broth. Finally, the prepared solution was placed in the incubator at 35 degrees Celsius for 5 days for better growth to be utilized for machining. As already discussed, EN19 alloy steel has been utilized in an effort to extend my PhD work, having worked on the same material. Separate samples from cylindrical bar were prepared for machining with different microorganisms, each having 22 mm diameter and 5 mm length with total surface area of 11 square centimeter. Finally, the samples were dried after rinsing them with distilled water and 75% ethanol before further use. In order to calculate metal removal rate, the samples were first rinsed with sterile distilled water after removing from microbial solutions. Then, mass of workpiece was measured with a weighing machine. Finally, based on the mass before and after machining, SMRR was calculated based on the given formula. So, the current table provides an overview of SMRR results in case of fungus. The experiments have been conducted up to a period of 8 days, wherein readings have been drawn after a regular interval of 24 hours. The successive weight readings were observed, based on which change in weight and SMRR was calculated. Thus, the highest SMRR value has been 0.098 mg per hour square centimeter, which decreased to 0.040 units after 192 hours. Similarly, SMRR results have been tabulated here for bacteria. Based on the analysis, the highest SMRR value has been 0.227 mg per hour square centimeter, which decreased to 0.203 units after 192 hours. This slide presents a graphical comparison of SMRR variation with time between fungus and bacteria. There exists a huge gap of 0.129 units in the highest SMRR values of both, with bacteria taking the lead. Talking about the trend, there has been a steep fall for fungus due to high initial reactivity, while, in case of bacteria, the rate has been gradually decreasing, hence provides better performance. The study presented the feasibility of both bacteria and fungus for machining alloy steel, due to continuous weight reduction. However, decrease in SMRR may be either due to less availability of sucrose for acidolysis, or change in pH. Further studies will be oriented towards optimizing physiochemical parameters such as shaking rate, pH, temperature, cell concentration and time for better biomachining performance. The study has been published in Proceedings of International Conference as per given information, and is available online for a detailed reading. I thank you all for spending your valuable time to go through the project information. Kindly subscribe to this channel for further updates on different projects.